Hello friends, today I am going to discuss the concept of relativity and frames of reference. Introduction. The term relativity comes from the word relative, that is, in relation. In this universe, everything is relative. There is nothing like absolute rest. If you think that you are sitting somewhere and you are in a state of rest, then my dear, you are wrong. You are also in the state of motion. Because if someone is able to see you from outside the earth, suppose from the moon, then you are also moving. Therefore, everything is relative. Now here question arises with respect to which we can study the motion of another object. This problem is solved with the concept of frame of reference. So definition, the frame of reference is defined as any coordinate system with respect to which one can study the motion of the another object. For example, a bus can be a frame of reference with respect to which one can study the motion of another object. I have used the term coordinate system. Now what is the meaning of coordinate system? In mathematics, you must have done these three axes, that is x-axis, then there is a y-axis, then there is z-axis. Now if you say there is a object P whose coordinates are 1 and 1, it means the object is placed at a distance of for example 1 centimeter from x-axis and 1 centimeter from y-axis. So this is the meaning of coordinate system. I repeat again, the frame of reference is defined as any coordinate system with respect to which one can study the motion of the another object. For example, a bus can be a frame of reference with respect to which one can study the motion of another object. Now types of frame of reference. Inertial frame of reference. This you can understand only if you know the Newton's first law or law of inertia. So what is that? It is very common. Remember or forgot? Let us revise it. Newton's first law is that a body at rest will remain at rest. A body in uniform motion will remain in uniform motion until and unless some external force is applied on it. Here a body at rest will remain at rest until and unless some external force is applied on it. Is called law of inertia of rest. A body in uniform motion will remain in uniform motion until and unless some external forces applied on it is also called law of inertia of uniform motion. Thus, inertial frame of reference is that frame in which the law of inertia is obeyed. In other words, the non-accelerated frame of reference is called inertial frame of reference. Why the non-accelerated frame of reference? Because if a body at rest, it means the acceleration is 0. If a body is in uniform motion, it means the acceleration is 0. So it must be a non-accelerated frame of reference. Now non-inertial frame of reference, it should be simple for you now if you understood the inertial frame of reference. That is, non-inertial frame of reference is that frame of reference in which the law of inertia is not obeyed. In other words, the accelerated frame of reference is called inertial frame of reference. Can you give an example of inertial frame of reference that is non-accelerated one? The simple answer is nothing can be perfect inertial frame of reference according to me. I might be wrong, but we consider Earth as an inertial frame of reference because acceleration of the Earth is negligible and Earth is a very, very big object. So this is the introduction about the relativity and the frame of reference. Now, frame of reference, on the basis of this, the theory of relativity is divided into two types. Special theory of relativity. This theory deals with the inertial frame of reference, that is non-accelerated frame of reference. And general theory of relativity. This theory deals with the non-inertial frame of reference, that is accelerated frame of reference. So my dear friends, in the coming video lectures, I will discuss with you about the various concepts of the theory of relativity, especially the special theory of relativity. Now please search our website venusscience.com for further notes. Please subscribe and like our channel. Thank you. Thanks a lot.